This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
What is leflunomide and how does it affect pyrimidine synthesis? Answer: leflunomide is an immunosuppressive drug that functions by inhibiting dihydroorotate dehydrogenase, a key enzyme in the pyrimidine synthesis pathway. Question: how do 5-FU and capecitabine function as drugs? Answer: both 5-FU and capecitabine are antineoplastic drugs. They work by forming 5-Fahrenheit dump, which then goes on to inhibit thymidylate synthase, a key enzyme in pyrimidine synthesis. Question: what is hydroxyurea and how does it affect purine and pyrimidine synthesis? Answer: hydroxyurea is an immunosuppressive and antineoplastic drug that functions by inhibiting ribonucleotide reductase, a key enzyme involved in both purine and pyrimidine synthesis. Question: how do methotrexate, trimethoprim, and pyrimidine function as drugs? Answer: methotrexate, trimethoprim, and pyrimidine are all drugs that function by inhibiting dihydrofolate reductase, a key enzyme in purine and pyrimidine synthesis. These drugs decrease the levels of deoxythymidine monophosphate in humans, bacteria, and protozoa respectively. Question: what is CPS1 and where is it found? Answer: CPS1 is an enzyme involved in the urea cycle and is found in the mitochondria of liver and kidney cells. Question: what is CPS2 and where is it found? Answer: CPS2 is an enzyme involved in pyrimidine synthesis and is found in the cytoplasm of most cells. Question: what is the mechanism of action of leflunomide? Answer: leflunomide is an immunosuppressive drug that works by inhibiting the enzyme dihydroorotate dehydrogenase, which is involved in pyrimidine synthesis. This inhibition leads to a decrease in the production of pyrimidine nucleotides, which in turn leads to a reduction in the proliferation of immune cells. Question: how does 5-FU and capecitabine inhibit thymidylate synthase? Answer: 5-FU and capecitabine both form 5-Fahrenheit dump, a molecule that mimics the natural substrate of thymidylate synthase. When 5-Fahrenheit dump binds to thymidylate synthase, it forms a covalent bond with the enzyme, effectively inactivating it and inhibiting the production of thymidine monophosphate, an essential pyrimidine nucleotide. Question: how does hydroxyurea inhibit ribonucleotide reductase? Answer: hydroxyurea functions as an inhibitor of ribonucleotide reductase, an enzyme responsible for the conversion of ribonucleotides to deoxyribonucleotides. Hydroxyurea binds to the enzyme and prevents it from functioning, thereby inhibiting the production of deoxyribonucleotides, which are necessary for DNA synthesis. Question: how do methotrexate, trimethoprim, and pyrimidine inhibit dihydrofolate reductase? Answer: methotrexate, trimethoprim, and pyrimidine are all drugs that function as competitive inhibitors of dihydrofolate reductase, an enzyme that catalyzes the conversion of dihydrofolate to tetrahydrofolate. These drugs bind to the enzyme and prevent it from functioning, thereby inhibiting the production of tetrahydrofolate, a necessary cofactor in the synthesis of purines and pyrimidines. Question: what is the role of CPS1 in the urea cycle? Answer: CPS1 is an enzyme involved in the urea cycle, a metabolic pathway that converts ammonia to urea. The urea cycle takes place in the mitochondria of liver and kidney cells. CPS1 catalyzes the first step in the cycle, the conversion of carbamoyl phosphate and ornithine to citrulline. Question: what is the role of CPS2 in pyrimidine synthesis? Answer: CPS2 is an enzyme involved in the pyrimidine synthesis. Pyrimidine synthesis is the biosynthesis of the pyrimidine nucleotides uridine and cytidine. CPS2 catalyzes the formation of carbamoyl phosphate, which is then used in the synthesis of pyrimidine nucleotides. It is found in the cytoplasm of most cells. Question: what is the mechanism of action of leflunomide in treating autoimmune diseases? Answer: leflunomide is an immunosuppressive drug that is used to treat autoimmune diseases such as rheumatoid arthritis. It works by inhibiting the enzyme dihydroorotate dehydrogenase, which is involved in pyrimidine synthesis. This inhibition leads to a decrease in the production of pyrimidine nucleotides, which in turn leads to a reduction in the proliferation of immune cells, particularly T and B cells. This results in a reduction of the inflammation and damage caused by the autoimmune response. Question: what is the mechanism of action of 5-FU and capecitabine capecitabine in cancer treatment? Answer: 5-FU and capecitabine are both antineoplastic drugs that are used in the treatment of various types of cancer. They work by inhibiting the enzyme thymidylate synthase, which is involved in the production of thymidine monophosphate, an essential pyrimidine nucleotide for DNA synthesis. By inhibiting the production of TMP, these drugs effectively halt the ability of cancer cells to divide and replicate, thereby slowing or stopping the growth of the tumor. Question: how does hydroxyurea inhibit the growth of cancer cells? Answer: hydroxyurea is an antineoplastic drug that works by inhibiting the enzyme ribonucleotide reductase, which is responsible for the conversion of ribonucleotides to deoxyribonucleotides. By inhibiting this enzyme, hydroxyurea effectively halts the production of deoxyribonucleotides, which are necessary for DNA synthesis. Without the ability to synthesize DNA, cancer cells cannot divide and replicate, thereby slowing or stopping the growth of the tumor. Question: how does methotrexate inhibit the growth of cancer cells? Answer: methotrexate is an antineoplastic drug that functions as a competitive inhibitor of dihydrofolate reductase, an enzyme that catalyzes the conversion of dihydrofolate to tetrahydrofolate. By inhibiting DHFR, methotrexate effectively reduces the production of tetrahydrofolate, a necessary cofactor in the synthesis of purines and pyrimidines, which are essential for DNA synthesis. Without the ability to synthesize DNA, cancer cells cannot divide and replicate, thereby slowing or stopping the growth of the tumor. Question: how does the urea cycle help in the detoxification of ammonia in the liver? Answer: the urea cycle is a metabolic pathway that takes place in the liver, which converts ammonia to urea. Ammonia is a toxic byproduct of protein metabolism that can accumulate in the blood and cause damage to the brain and other organs. The urea cycle converts ammonia to urea, which is less toxic and can be excreted in the urine. This process helps in the detoxification of ammonia and protects the body from its harmful effects. Question: how does the deficiency of CPS2 affect the pyrimidine synthesis? Answer: CPS2 is an enzyme involved in the pyrimidine synthesis. The deficiency of CPS2 leads to a reduction of the synthesis of pyrimidine nucleotides, which are necessary for the synthesis of DNA and RNA. A deficiency of pyrimidine nucleotides can lead to a variety of symptoms, including anemia, immune dysfunction, and developmental delays.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the First Aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.